So today we're going to look more into tangents and tangent lines and the properties that go along with those. So quick review, a tangent line is a line that intersects a circle at exactly one point. And that point is called the point of tangency. So we have a rule that says a line, it will be tangent to a circle if and only if it is perpendicular to a radius or radii, or I guess radius, drawn to the point of tangency. All right, so a line will be tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So here's our circle with the center is P, and this appears to be a tangent line intersecting at one point. So if I draw in the radius from the center out, that radius is always going to be perpendicular to that tangent line. If it's not perpendicular, then it's not a tangent line, all right? But if it is, then it will always be perpendicular. So we're going to be able to use a lot of our right triangle rules with this property. So it wants us to determine whether or not segment AB, right here, is a tangent to this circle. Well, if it is, as we just said, then that radius drawn from P out to A would be perpendicular to AB, which means that this figure would be a right triangle. So how do we determine if it's a right triangle? We use Pythagorean theorem. So we would just check 5 squared plus 12 squared to see if it equals 13 squared. If it does, then it will be a right triangle. So we've got 25 plus 144 equals 169, and those two sides are indeed equal. So AB, segment AB, is a tangent. Okay. Example 2, it says if segment JK in each picture is a tangent to circle P, then find the missing part. So again, when I look at this, if JK is a tangent, EJ is a radius, I know that that makes a right angle. So this time we would do 7 squared plus 15 squared equals x squared, because the missing part is the hypotenuse. All right, so we've got 9, plus 225 equals x squared. So x squared equals 274. All right, so x is either going to be the square root of 274, and we could try to see if that breaks down any, but I will let us go to my calculator and actually take the square root of that. So we get 16.55. There are no units, so we would just leave it like that. Okay. The next one. Now, notice the difference in A, where x is labeled to be the whole hypotenuse. This time the x is only this part. Only that part. And that's important to recognize. It does not represent the whole hypotenuse, or we'd have the little caret thing like we have back here. So the radius, this extra part of that segment, since it is radius, is going to be 6. So this whole side is x plus 6. So when I go to do the Pythagorean theorem, I've got 6 squared plus 14 squared. And let me add in, because here's where the right angle would be, equals the quantity x plus 6 squared. Now, we haven't done a lot of problems like this. All right, 6 squared is 36. 14 squared is 196. When you square a quantity, you have to write it twice and then distribute it out. It does not equal x squared plus 36. That will be wrong. You're going to miss the middle term. All right, so we've got 12, let's see, 232 equals, when I distribute this out, I'm going to take x times both of those things. So I'm going to have x squared plus 6x, and then I'm going to take 6 times both those terms. So I'll have another 6x plus 36. So we've got 232 equals x squared plus 12x plus 36. Now, I'm going to finish solving this with you, because if you remember from Algebra 1, we have a quadratic. And when you have a quadratic, in order to solve those, you have to set it equal to 0. And then you would need to factor it. Now, we haven't reviewed factoring. So if you get a problem like this, I'm going to accept that actually that you can just get it this far. But I am going to remind you how to factor this. This is one of the easy ones. We have a 1 in front of the x squared. So what I'm looking for are two numbers that multiply to be negative 196, but will add to be 12 in the middle. All right. And then you break it down basically into two different quantities again. So I know I have x and x. A little trick to factoring: when the constant is negative, all right, then I know I'm going to have 1 plus 1 minus. So we're looking for two numbers that multiply to be 196. And I know 14 and 14 works, but that's not what we want. So I've got 7 and 28. That's not going to work. Wish I had my graphing calculator with me. Let's see here. So we've got 14, 14, I've got 2, 7. I tried 4. Let's see. When you can't factor it, the other way to do it, because for some reason I'm having what I call a brain fart, we do the quadratic formula. So very quickly, I'm going to do opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So we've got negative 12 plus or minus 144 minus well, that's going to get me a, no, it's not. Hold on. Oh, 4 plus 144. Square root of 928 over 2. And then the square root of 28 is a decimal. So we've got negative 12 plus 928 square root. So I've got 9.23, or we've got negative 12 minus. And that will get me a negative, which doesn't make sense. So this will be my answer. All right. Sorry you had to go through that with me. This is how far I would expect you to get your answer if you get a problem like that. I think I've been pretty careful. I forgot there was one like this in the notes. All right. But if you can get me to the quadratic, all right, then you'll be good. If you can try to factor it and you want to keep going, good for you. If not, you can always do the quadratic formula. But again, not looking for that right at this moment. All right, the last example. Again, notice that the 6 that's labeled out here does not represent the whole side. All right, there's this little piece here that's also 4. So all of this would be 10. Now our right angle is where the radius and the tangent meet. So that 10 is the hypotenuse. So this time we would have x squared plus 4 squared would equal 10 squared. Going to be a lot easier. So we've got x squared plus 16 equals 100. Subtract the 16, and we're going to get 84. And then x would be the square root of 84, which Hit the right buttons. There we go. So we're going to end up with either 2 times the square root of 21 or 9.17. All right, and just read the directions so you know whether to leave it as a radical or as a decimal. All right, so that's part of the tangent. One more thing. All right, so if 2 segments coming from the same external point are tangent to a circle, then they are congruent. So you'll have a picture that looks like this. So this from point Q, you've got a tangent coming down here to point R, and then another tangent coming down here stopping at point P. Our rule says those 2 tangent segments will be congruent. So you would simply do 12x minus 13 equals 9x plus 5. That allows us to solve for x. So I'll subtract 9x. And we get 3x minus 13 is 5. Add 13. Divide by 3. So x is 6, but we want PQ, which would be the 9x plus 5. So we're going to do 9 times 6 plus 5, which will get us 59. And then we label it. That is the measure of PQ. And then our last tangent rule. If a polygon is circumscribed around a circle, then all the sides are tangent. Now, to be circumscribed, it says the circle must touch all the sides of the polygon. All right, so notice in this picture, all right, we've got all these sides of the polygon are all touching the circle in one place. They all must touch. Can't be 3 out of the 4 in this case. It would have to be all the sides, all 4 of them. So now we can apply the rule up above. All right, so from these external points coming down, these tangent segments just to the points of tangency will be congruent. So this 14 will be the same over here. Okay, these are not midpoints. We have to use the tangent from an exterior point rule. All right, well, if the whole side is 26 and this part is 14, if I subtract these, then this side is 12. So now I can apply the exterior point rule over here. So that makes this part 12. Then again, I can subtract 22 minus 12 is 10. So that gets me this is 10. And then this segment 16, so is this. Once I have all the individual parts, now I can find the perimeter, all right, of the polygon. So one side's 26, one side's 22. This side over here is going to be 26, and this side over here is 30. So your perimeter is going to be the 30 plus 26 plus 22 plus 26. We add those all up. $104, and there are no units, so you can leave it like that. All right, so those are your tangent rules that you're going to be using today. Let me know if you have any questions.